Hello, everyone. Welcome to the live stream today, or if you're watching this after the fact, the video on demand. I'm Noel here from Tested and joined by
Jen from Tested.
And we're so happy to have you here today because we've been looking forward to this for a long time. Jen, you've been working on an amazing laser cutter project in collaboration with Glowforge. It's there right now for people who may have Glowforge or a laser cutter, but this is kind of your next step after you did that diorama, the book note diorama.
Yep. Yeah, this is sort of the next evolution of my laser cutting skills and kind of a new way to look at a model kit.
So we're going to give people a couple minutes to settle in. Hopefully no technical difficulties. If you can't hear us, let us know in the chat. If you're watching this after the fact, just bear with us as we're going on. And please, this live stream is also made possible by our Tested members. So the members in the chat right now, send us questions. Jen will be answering questions about just laser cutters and laser cutting and designing for laser cutting.
Yeah, all of this.
And all the things that you've learned, because I'm sure it's been in your head for the past couple weeks and months. So for people who haven't seen this project, Jen, I'd love for you just to start off by showing off this project and kind of walking us through that design process, where the idea came from, how you come up with the idea when you know your materials are going to be laser cut wood or acrylic.
Yeah, so I guess going back to the beginning of the process, the first thing that sort of inspired this was the pumpkin as an enclosure. So we did these dioramas before that are made to go inside of a bookshelf, and I was thinking about like what other format could we do for Halloween. Obviously a pumpkin came to mind, and there are these really cool carvable foam pumpkins. So this is fake. This is totally fake foam pumpkin. And so I was able to cut into it with a hot knife and kind of get this tree filigree design on the front, and that allowed me to figure out how much real estate is there to work with inside of this as an enclosure.
Right.
So I started off with this shape, and then I started sketching out these different ideas of and I wanted to do a haunted house. So what could this haunted house look like inside of a pumpkin? So here's some of the initial sketches.
Oh my gosh. Okay, so we have a close-up here of your design. You knew you want to do a haunted house. There's like a wide range of kind of haunted house, like archetypal haunted house designs. And already I want to point out like the hand carving you did in the pumpkin. That's very much like your aesthetic.
Yeah.
Right. I remember the book nook you did, which was made to look like, the size of a book is supposed to fit into a shelf. You had like the similar tree design.
Yeah.
Very much like hand drawn almost.
Yeah, and I think that's what I was really going for. Like, how can you make something that's made out of this flat, rigid material look like it has a little bit more life and a little bit more movement? So for me, I use a drawing tablet. Like I use a Wacom tablet that talks to Illustrator, and I draw as if I'm drawing in my sketchbook. Sometimes I even trace, like I'll photograph my sketchbook and then actually trace that into the computer. So it's a very hand-drawn, sort of organic feel to the digital file.
Because with the laser cutter, the versatility of the vector here, it's not a flat fixed size image. They're basically it's math of the endpoints and the curves, and you can certainly design in a program like Illustrator with perfect circles and rectangles and squares and have all that stuff. But what you've done is you want a more organic look, hand-drawn look.
Yeah.
And by literally drawing on paper first and then porting that over with the scan or your tablet, you can incorporate that into Illustrator.
Yeah, I use like a brush tool. So I'm actually like painting the lines as opposed to like drawing them as though it was a pen, the brush tool, and I can change the size of the brush. And that gives me like the same type of feel of these like flowing wavy lines. And I really like the way that feels, especially then when you etch it. So like the etched details on here are all kind of like all of these, the little thatch pieces in the roof, those were all drawn with like a brush to get that flowing organic form.
So you still get a texture as well.
Yeah.
Well, let's take a look at these drawings here. And so you have different perspective views.
Yeah, I like to go through different, I was trying to figure out what shape the haunted house should be. So like there's so many, I looked at all these different reference images online of haunted houses and pop culture and different fan art and things. And I went through a lot of different sort of layouts of how the house would actually be shaped.
Wow. So when you have a drawing like this, you're not thinking of this as one sheet of material, flat facade. You're already thinking, how inset these may be.
Yeah.
And I already see you have like a top-down view, and are you fundamentally, are you thinking of this as like it's a different like this organic shape hidden underneath are like boxes or rectangles?
Totally, because as much as I wanted to be organic, like I'm still limited to the form factor of this is a flat piece of material.
Yes.
It's about an eighth of an inch thick.
Right.
I can only cut, all of the edges of the cuts. There's no miter cuts on a laser. It's all perfect 90 degrees. So everything that you're doing ultimately has to be sort of squared. And so
Right.
underneath of all that organic surface texture has got to be a geometric form. And so when I'm doing the drawing, I have to think about, how if I want to make a roof that's pointed at the top, how are those two pieces of material going to line up and interact in space because of the dimensionality of the plywood?
Yeah, you mentioned joinery, which becomes this whole
Yeah.
thing because you're laser cutting and because you're cutting at a 90-degree
Mhm.
angle. There are only so many traditional ways that cut pieces of the same thickness can be connected if you're not using, glue, right? If you actually
Yeah.
want them to have a physical mechanical
Right,
connection.
exactly. I can show. So this is one of the early.
Oh, perfect.
Yeah, this is one of the early versions. So talking about that box format, this was my first version. So I figured out,
Yeah.
like, I have tabs at the top. I don't know if you can see those. So I have tabs at the top, and what that allowed me to do is to hide all. Instead of having finger joints along the edges here, there was this sort of hidden. I don't know. This isn't even really a joint. Where it's joined is on the top here. So if you look,
Oh, I see. So
everything connects into the roof pieces.
okay, well, let's take a step back. You finger joints. So if you're talking about a right angle connection,
Mhm.
right, two pieces of material, the way you can have them connect by having kind of like puzzling them together, right, where
Yeah.
they fit at an angle and this finger joint where it connects like that. You don't have them here because they're basically boxed in from the top and the bottom.
Exactly.
And
So
that hides or it eliminates the need for this kind of that puzzle piecing on the edge.
exactly. This was my first sort of version that I made. But when I looked at this compared to my sketches, like, these have so much more movement in them, and this seemed really limiting. So this seems like, this looks like a laser cut box. Like,
Yeah,
this doesn't have that much personality. So I had this idea to make the walls kind of crooked. I was like, well, what if the walls don't have to be perpendicular? Like, maybe they're not straight up and down. Maybe the walls tilt on an angle. So this was the first proof of concept that I did for that. And it's just one little section of the house. But if you look at it from the front, you can see that the walls, instead of them being perpendicular, they have this, this one juts out at this angle and this one juts out at this angle. So this front face and the back face are flat, but then I slotted in the two side walls on that angle.
Fundamentally, you're just adding one extra axis, but you're still, because you're doing that boxing in, like I see on the bottom there, you have the same kind of holes that allows you to add one extra level of dimensionality. And I like that it's not even, they're not straight edges. Like you're hiding the seam here by using little overhangs.
Yeah, I figured if I could disguise the finger joints in the design, so it looks, I made the lines where the boards are separated, even though they're not actually separate pieces. The engraving makes it look like where the overlaps are is actually just part of the structure.
Wow, that's super cool.
So this was the first moment where I took this outside, I put some lights in it, I took this outside, and I was like, okay, this is gonna work. I was super excited because this I was kind of like, and then when I saw this, I was like, this is gonna work. This is how I'm gonna do it.
Can you talk about the roof here and
Yeah.
how that's done? Because it's not this flat top, but you're still kind of also designing a way to box it in. But these angles, that's not an easy thing to get that to match.
Yeah. So a lot of the haunted houses that I was looking at have this these sort of square uh roof pieces, like this front piece here. Let's see if I can show that off to you. Where the pieces sort of come in together, but they don't come to a point. And I really like that idea, and I made a bunch of foam core prototypes of that. See if I can show some back here. So here's one of those foam core prototypes.
So like trapezoidal pieces, where even with the foam core seems to be a natural prototyping material, though.
Yeah, it's a great analog for plywood. It's a little bit thicker, but it's nice because it has the same type of dimensionality. You've got, it's a wide flat sheet. It's similar thickness. The challenge is that when you translate this, like foam core is a lot softer. So when I translate this shape into the plywood, what I was realizing is that these edges are not going to line up perfectly. You're going to have all these visible seams because, again, if you think about the fact, if I was going to cut this and make a box like as a carpenter, you would cut your edges on an angle so that everything matched perfectly. You'd cut the miters at the right dimension. But again, with the laser, you've only got that 90-degree cut. So how do you get parts that are not at 90 or 45 degrees to line up? So these angles are not quite 45, but I figured out a way to kind of hide that top joint with this sort of like roof rail thing. Let's see if I can show one of these. I think I can grab this one. So this was my solution for hiding that seam on the top, and it's a decorative piece. So it's like that little spiked railing on the top of the roof, and it fits in that little space. Oops! It fits in that little space so that it hides the seam on the top. So you can see how that works.
And you're only fixing it on the side. Is that with glue or?
Yeah, so it's hard to see because it's so small, but I figured out this profile of these two pieces, and I cut a little section that fits perfectly in that space. And so it rests, this one's longer because this was just the prototype, but it rests in that little nook. And that's where you can either glue it on or you can just kind of like place it into the roof to hide that.
It's like another way of sandwiching in, right? Except not without the hole, it's just kind of a bracing in. How do you design, because you have, I'm looking at this, right? And you have a triangle here for which it's got to be right angles that pop out there. This piece needs to align with that piece, align with two, like you're connecting three pieces together.
Yeah.
How do you design for connecting three pieces together if you're not doing this presumably in a CAD program?
Yeah, I'm sighing because it was a lot of mental gymnastics. So I have a pretty good idea in my head of how all the pieces are going to go together, but everything has to be done really precisely so that when you cut it, it's going to fit. So I did a lot of, and we've talked about this before. So we both think in vectors. I'm learning CAD software and I'm getting better at it, but I'm still much faster at Adobe Illustrator. And so what I was doing is I would make this face, I would make up this profile, and then I would figure out the sort of like projection of that face onto the next side. So I'd figure out like, how do I explain this? If these walls are going this way, and I know that the material is 1/8 of an inch thick, I would make an 1/8 of an inch wide rectangle and say, okay, that's the profile of the side of it, project that onto the front one. And I did that for every single piece of the geometry. So for these ones, I'm like, okay, the walls are not perfectly 45, but whatever this tab is has to be exactly 90 degrees from that face. So that I would take a square and you rotate. It's a lot of reference off one, reference off the next one. You have to keep it all in your head.
One way to think about it is if you think of it like if you disassemble this, you're looking at it from one flat face at a time. Like you exist in 2D, even though the thing you're making is in 3D. And when you rotate it, the only thing that you know is the thickness of the material. That's your guiding principle. That's how wide these holes have to be. And then you know that like when you align them, when you kind of align the bottoms to each other, then this line has to cross section that part. And then you rotate it again.
Yeah, and you have to have a it's kind of like, why would you do it that way? But it worked. I mean, lots of it are, I cut this at least a dozen times, and you think that it's going to work. You cut it, you realize you didn't totally understand how that geometry was going to interface. So you're like, okay, I need to move that another 1/8 of an inch, cut it again, see how it works. So it's a very brute force process to do it in a two-dimensional way, but eventually it got there.
Awesome. So you got this. You're very happy with this design. This is one tower, but a whole house, as I'm seeing, is many layers of that. So is it a matter of grafting the principles of this onto kind of your overall form?
Yeah, I like to think about it in terms of like like a base structure and then the additional pieces. So I was thinking for this house, let's see here, I'll go with the simple one without all the details, so it's easy to see. The main house, this is what I was thinking of. The main house was my base structure. So I started off with what I was calling A and B. So you've got a front and back, and I know that these two faces are flat. Then I have crooked walls on both of these, and then I continue building onto the geometry from that base piece. So then I added this little side section. I added a little dormer. I added a chimney, which ended up over here. So it all just kind of like accumulates on top of the main geometry. So I'd solve for each, how does this section interface with this side wall? And then how does the dormer interface with the roof? And you just kind of keep building from there.
I think that's a really smart just way to approach a complex project.
Yeah.
Because you're fundamentally using you're solving the same problem over and over again, one bit at a time. Because if you ask me, design a beautiful haunted house with multiple layers, I wouldn't know how to approach that. But the way you break it down, you're just solving one major structure first.
Yeah, exactly. And what the learnings from this main piece, then I was able to be like, okay, I figured out how to solve that. Now I can apply that to the next section, and you get better at figuring it out as you go.
Right. And I see your labeling too. It's a nice thing, again, because you're using laser cutter and you can engrave, you can cut. I'm going to show people you have even on your pieces labels. So how do you keep track of, is that a way that you're kind of, when you laser cut pieces and you have, dozens and dozens of pieces there,
Totally.
This is how you can keep them matched. I see actually like engraved left wall.
So
right
that's
there.
actually, so these are scraps from the book nook.
Okay.
That's labeled from the book nook
Oh,
pieces.
I see. Okay.
I'll give a little plug here, because one of the things I've been really enjoying about working with the Glowforge is the onboard camera. So the industrial level lasers that we usually use here don't have that feature, and I save all of my scrap material. So when I cut hundreds of book nooks, I saved all those offcuts because I'm like, that's plywood. It's it's expensive. Let me save it. And they're little pieces, but it's hard to do stuff with them when you don't have the ability to see, like in the machine, to see where you're going to lay out your design.
Right.
But having the camera inside of the Glowforge means that I can put my book nook scraps in there and use every last piece. So almost all of my prototypes I cut out of book nook scrap pieces. And I was able to utilize basically no new material in prototyping because of that. So yeah, that left wall is an artifact from a previous project from last year.
Okay, makes a lot more sense now. Well, and I'm sure your scraps end up being just like skeletons.
Yeah, exactly.
Like you want to use as much the point of pride to have nothing left.
Yeah, use every part of the animal.
That's awesome. That's awesome.
Yeah, these little labels help. So when you take all the pieces out, obviously some of them start to look the same. And in my mind, when I have like working again from that base structure, like this is A and B, and then I work outwards from that. And so I know then when I start attaching things like windows, I know, oh, this is the window that goes to L1. This is the window that goes to F2. So I can sort of keep this reference system. And so even though on the final piece, obviously there's no letters, I can look at this and be like, yep, that's H, that's I, because I've worked with them enough to remember the codes.
What are your thoughts on symmetry in design? It's a thing that when I work in Illustrator, I see a lot of benefits of designing things to have symmetry because you can use either one piece of material can work on both sides and things get less confusing. But I also fall into a trap of things you lose an organic feel. You could lose an organic feel.
Yeah, that's a great question. I mean, underneath of all the layers of sort of texture and details, it has to be symmetrical to some degree. But in my mind, symmetry is like sort of the enemy because it looks more like this. It looks more, manufactured. Whereas when I want things to look like they're real in nature, like the trees, for example, none of these trees are the same. I slightly changed all of them. And maybe I took the profile of one tree and then I selected a couple nodes and just scrambled them because I don't want everything to look like it's, mirror images of each other. Yeah, it's hard to take something that has to, it has design constraints of the material and the cut, your cut angle. Making it asymmetrical adds an extra level of complication.
Yeah, but I guess it feels like it's a worthwhile step. It's a thing I should remind myself to do more often, is go the extra step and add a finishing touch of just making it not symmetrical, stretch out a vector, stretch out a point at the end if we want something to look a little more organic. Okay, so you're at this point where you have your major structures. You've added these really interesting overlapping finger joints, which works with this aesthetic perfectly of the wooden boards. Where do you go from here is it detailing now?
Yeah, detailing and also adding the little embellishment. So like there's two levels of it, right? Because you can engrave on the surface of your shapes, but you can also start to add layers and add more dimension that way. So that's I had a lot of fun adding the pieces. I can show you the next next step. So this was after that. This was the next iteration. So I added.
Wow, we'll give people a close up of that. Yeah, that's so cool.
And you can see I make notes to myself. So like here's an arrow saying like this window should come a little bit lower. You know, whatever notations, I just draw right onto the prototype.
And I see a layering right there.
Yeah. So that was designed to hide these tabs. So you see how on here you can see the tabs coming
okay,
through?
that is super cool. Right.
So this is that thing where like this belies the organic stuff. This is like, oh, look, and it has to be a square because this is the material's only going to be one dimension. I can't make this any other shape. Yeah. And I was like, I don't like that I can see that that's a square. So I added an extra layer onto the roof pieces so that I hide. And these are arranged so that they hide all of these little tabs. And then also, if you engrave underneath of them, I drew on it on this one in pencil. You can see I started to draw on them. And I realized, oh, hey, that actually looks really cool because it adds this extra layer of like, it looks like that patch was put there to hide a hole in the roof, you know? Yeah. And then, you know, layering pieces on the windows. So like this is now 2 layers on top. So you've got the sort of, I don't know what you call that, the spacing in between the windows, and then there's an additional layer on top to add like the window ledge and the arches on top of it, just to give a little bit more dimension.
And that's just glued on. Do you find a point where you want to balance between things that are like physically, mechanically connected versus stacking, and the balance of that? I see you sometimes laser cut. You know, let's make a cylinder. Well, then you're just going to stack a bunch of circles together, and at some point, it also then betrays the process.
Yeah. I was looking at a lot of different. I do so much research when I do these projects, so I looked at a lot of laser cut kits out there, and I was like, okay, how did they describe that geometry? Did they do it by stacking circles, or did they actually segment out the flat panels of the face? Yeah, I think it's a combination of that combined with thinking about how it's actually going to be cut. So sometimes if you want to get into a whole bunch of detail that's sort of like described on the surface in etching, it starts adding up your engrave time exponentially. So if I was going to engrave a whole bunch of details on here, all of a sudden it becomes a 2 or 3 hour long engraving process. So by doing these sort of cut layers, it does add a little bit extra on the end because you're having to glue things on, but this will cut out much faster than I'll be able to engrave to get some of that geometry.
And for people to understand, the laser cutter, the things you're controlling are the power and the speed.
Yeah.
And so when you engrave, it's basically like a traditional inkjet printer. It's going at a certain resolution, and you can adjust those, but it's basically going back and forth and inscribing on, and you get a lot of benefits of that. You can, you know, engrave a picture of something, for example, but you could also do these vector lines, vector engraves or etches, which moves as fast as the laser wants to move. And you get like, you can actually draw that way.
Yeah. So all these details on the roof, all of the lines between the boards, these are all, instead of being engraved, these are all cuts, but they're shallow cuts. So you run it on a pretty high speed, so the laser's moving quickly, but it's on a lower power setting, so it's not going to pierce all the way through the material. And so instead of, like, if I were to make these all you know, strokes with a weight to them and it was engraving, it would have to go back and forth, like you said, over that whole area, the whole surface area to get that. But in this way, it's just drawing really quickly. It's just going, okay, there's a thatch and there's a line and there's a line, and it moves way faster. So thinking about the sort of execution in the end, one in the design of like, what is the most optimal way to get this detail on there without spending hours and hours on it.
And then I also like, even in your prototypes, you're using, you know, a light colored wood, and I don't know if this is intentional or not, but you know that the burn on the edge is going to be darker, and so you have natural contrast. And when you're stacking things 2 or 3 layers thick, all that just has this nice passive dimensionality to it as well.
Yeah, I love this. Is like so appealing to me. I love the look of this, even though it's, it's rough and there's notes all over it, but I like seeing the kind of the materiality of it, and I like having the burn marks on the edges.
Totally. We'll take a couple questions from the chat. Scrolling back up. Thank you, everyone, all our members, for joining and posting questions. Christopher Madalena asks, he struggles to translate their drawings to SVG. You go to Fusion to get dimensions and export DXF, but it's not great. Any tips for precise dimension and fit in Illustrator?
So this is tricky, and it's tricky depending on which programs you use. What I like to do is a lot of referencing. So I'll use something that is a known size. So I actually use these gridded cutting mats a lot. If you're talking about translating something from a drawing, for example, I think that was his question, right? Translating from a drawing,
from Fusion, or typically he goes to Fusion to get the dimensions, but
Got
it's
it.
not a great process.
So I would say anytime that you're photographing a drawing or you're scanning a drawing, it's really good to have a reference with a known dimension on it. So we've done this before where I'll take this and I'll put a ruler on the page when I take a picture of it. Or if I've got, if I made my foam core prototype and I want to translate this digitally, I'll lay it on top of, I'll lay it on top of a gridded cutting mat. I make sure that my camera is as straight above, as perfect bird's eye view as I can get. It's not tilted, it's not off to one side. Make sure all of those grid lines are lined up. And then when I take that photo into Illustrator or into Fusion, I know that this grid is exactly 1 inch. And so I can scale the image so that it matches until that's exactly 1 inch. And then I know that the photo I took is going to match the real life dimensions with what I'm seeing digitally. So I'm not sure if that answers your question, but that's usually how I translate things.
Well, I think it's a really good point that it's a benefit of using a physical prototype first, because it's very easy if you just start in a design program, whether it's CAD or vector-based, to not have a sense of how big a thing is.
Yeah.
And it's oftentimes 10% too small, or or much too big, because you just don't have that. You're looking at a scaled laptop screen or computer screen, and even though you'll have the indicators of how many inches that is, like it's another reason if you start in Illustrator or whatever design program first, get to a physical prototype.
Yeah, absolutely.
I know it's very tempting. Yeah. It's like, oh, I want it to be perfect the first time, but just cut it out just so you know and can see and you can internalize how big something is.
Yeah, and even in a program like in Illustrator, obviously you can't orbit around in 3 dimensions because you only have 2 dimensions to work with. But in Fusion, you can orbit around that model and see, I think it's going to look like this, but it could still, when you cut it out, it could still be totally different, spatially, the relationships between the things could feel totally different. So yeah, that's what these prototypes are for. I made this specifically, and I cut it. I don't know if you can see this. I cut it in half. So I made this initially, and there's a seam up the middle of the house here because I put it in the pumpkin and I realized it was too wide.
Right.
And I wouldn't have figured that out digitally. I only figured it out in physical form. And I was like, nope, this isn't going to fit. Slice it up the middle. And then I took I literally measured this and put those dimensions into Illustrator. Hopefully that answers that question.
Let's see if there are any other questions that we have so far. Lots of people chiming in, having different experiences with different laser cutters. And I mean, you've had a lot of experience. You did some testing of laser cutters for Make Magazine. And if someone's looking to shop for a laser cutter and they don't have a sense of the different categories, let's say, right? Can you give a broad overview of what's the difference between a blue laser versus a tube laser?
Yeah, so a lot of the lasers that we have used here at Tested are CO2 lasers, which is it's a tube, and it's basically it's firing a laser beam inside of a glass tube with, I think there's CO2 gas in the tube, and it's using a series of mirrors to reflect the laser beam down into I guess it's called the nozzle of the laser, and that's where the beam is firing down onto your material. For a blue laser, just lost an earring. Whoops. For a blue laser, it's basically like a DVD reader or writer. So it's almost like a Blu-ray player, and there's no tube in that. It's just a optical sort of drive, and it's focusing the beam down. Those ones are a little bit more, I guess, portable because you don't have this giant glass tube. So if you had a machine that you needed to transport for some reason, they're good for that. They're really good at doing photo engraving. Like they do really high fidelity. They're not as powerful typically. They're equivalent to usually around a 40-watt CO2 laser. So they're on the lower power threshold. So you're using a blue light laser for things more like engraving as opposed to doing lots of cutting like this. In the realm of lasers that you might buy, you will mostly find CO2 lasers, I would say. They're far more predominant. And there's lots of different levels. So you have desktop sort of hobby level machines, which run anywhere between 15 to about 45 watts of power. And you can cut material 1/8 inch for sure. Sometimes you can cut some 1/4 inch thick plywood or acrylic. They're a little bit smaller in the work area size, but they also take up less footprint in your shop, and they're maybe like a foot, 18 inches tall, so you can fit it on top of a desk or a workbench. They're also in the lower price range. Then you get into sort of commercial level lasers, and they're looking at something like the size of almost a refrigerator. So it's much bigger. It's going to stand on the floor. You can go anywhere from 40 watts to about 120 watts of power. So you could be cutting through 1/2 inch thick plywood with a machine like that.
And even though with multiple passes you could approach 3/8 or 1/2 inch with a CO2 laser, I have never had great success, or I've always freaked out of how much smoke literally comes out of that. At that point, I'm like, maybe consider a different process.
Yeah.
Maybe consider a CNC or something.
Right.
If you need to hog out material. At that 1/8 inch or 1/16, that's like a really nice sweet spot for laser.
Totally. Yeah, and it's like what tool is the best suited for the process of what you're trying to achieve.
Yeah. We got a question from John Rudy, who asks, how do you control for surface scorching? I know it's something you actually lean toward and you like, but what are your favorite techniques if you want to tune material settings and maybe avoid some surface scorching?
So it's a lot of testing, and again, it's those two variables of speed and power. There's there's resolution, the DPI, and things like that. But typically, a higher speed and a lower power are going to give you less scorching. So what I always try to do, whether it's cutting or engraving, you have a little bit more room because you're going to see the engrave. As long as it's visible, you're going to see the engrave. For cutting, it's either cut or it's not cut. So I try to go for the highest speed and the lowest power that I can get away with. Usually if you're working with, most lasers will come with some material settings for you to start with, but I'll push that threshold. So again, higher speed, lower power is going to give you less scorching. You can also mask the material. So like for Glowforge, the proof grade plywood, those all come pre-masked. Keep in mind that anything that has a mask on it, when you cut it or engrave it, you're going to have to weed all of that masking off.
Oh gosh, that becomes. And I have a question about how do you what are efficient ways of getting rid of the masking, because it can become a laborious process. Are there tools you use, or do you maybe just peel off one side before you cut it if that's not going to be a visible side? You
can do that. So like if you know that the back of the material is going to be on the inside, you're not worried about scorching, you can peel off the masking on the inside first. I use a weeding tool. It's almost like a little, like a dental pick. It's got a needle point. It's like a little hook with a needle point on the end of it. And I use this thing. I wish I'd brought it to show you all, but it's a ring. It's a silicone. It's a big sort of like compartment that has a cross section in it. And what you do is you poke the needle end of the weeding tool into the masking, just barely. You just want to like pierce the paper, and then you can peel it back with that little hook. And then this ring, you put all the pieces of the masking into this ring, and it holds all of them. So really quickly, that's what I did for this. I wear this little weeding ring and really quickly poke, peel, stick it in the thing, poke, and really fast.
So you have a tiny little garbage can of your masking that when you stuff it in there, you pull it out, it can't come out because there's that crosshatch on top. It's also a consideration if you're doing your fast etch lines. it may give you the nice design, but also then requires more post-processing work because every little piece that you draw in is a piece you'll have to peel off for masking.
This design took, I mean, every single one of these boards was a separate piece I had to peel, because when you peel one, it's not going to take the next one with it. So every one of these, every little section of the roof thatch, it took me about as much time to weed this when I cut it in the proof grade as it did to cut it, because there's just so much detail. So masking can be used to great effect. Just keep that in mind. And then the speed and power settings for sure.
Perfect question for the next step in this is lighting. Barkley asks, what do you recommend for the lighting design, and at what stage do you plan out that part?
So it varies by project. For the Book Nook project, for example, the lighting was a really sort of initial part of the design process, because I built it as a kit where you would wire in all the electronics yourself. So I had to figure out exactly. I actually made cutouts for individual LED lights so that everything would sit perfectly in the diorama where I wanted the lighting to go. For this kit, the lighting was a little bit more of an afterthought. So it's a big open space on the inside. And you can kind of, what I did was to tuck some fairy lights in. So let's see if I can show one of these little fairy light packs. I don't know if I can pull it all the way out, but it's basically a little coin cell battery pack and a strand of fairy lights that goes in here. I have heard that it can be tricky to get the lights in the right position. Behind, like if you wanted the lights to go behind the windows, it can be hard to do that. So one thing I did with Book Nook, which in retrospect I probably should have done on this one, was I made a little holder basically that would glue, where you could glue the lights. So the light strand would feed through this little loop essentially, and you would glue that to the inside wall, and that allows you to keep the lights in position. And then when you put the whole thing together, the light strands are placed where you want them to be placed. So yeah, I would say think about it as much as you can in your initial design if you're designing for laser. The challenge is that not everybody's going to have access to the same, like for Book Nook, I wanted a way that you could do it without solder. So everything had to snap together. For these, this is just an off-the-shelf product. So when you're designing, think about what's going to be readily available, what's going to be easy for folks to implement depending on what kind of, technical setup and technical skills they have.
Yeah. And if you're doing a miniature with if it's diorama and you're representing a house, like think about how the internal space gets divided up. Is it one big space? Is it separate spaces? Do you want to have light bleed on the inside between the windows? And it's like just adding another prototyping step.
Totally.
Right? It's a thing that's very difficult to visualize on the computer until you actually put a light in there.
Yeah, and especially when you're working at miniature scale, like it's hard to get your hands into this little space to place the lights where you want to. So everything at miniature scale can be a little bit more complicated.
Lee Marsh asks, what are your design influences? What would you say your aesthetic gravitates towards? Is this a good example of it? And
yeah, I think so. A lot of movies, a lot of sort of like pop culture stuff. Like I looked at the haunted house for Casper, Addams Family, Cabinet of Dr. Caligari. Someone said that this reminded them of that because of all the crooked lines. So yeah, a lot of movie references. I think that my aesthetic is somewhere on the kind of like whimsical, I don't know, almost, I don't want to say Tim Burton, but like in a more sort of like whimsical fantasy world. It's not necessarily like sharp and dark and like gothic looking. It's a little more like playful, wobbly, wiggly lines, things like that. I don't know if that describes it, but I save so many folders. I don't know. Do you do this?
Yeah, absolutely.
Like inspiration folders?
It's the same folder that I eventually will do a project inspired by that.
Yeah.
It's like the placeholder. There's no vector files, nothing in there. It first is downloaded images from Google, and then, okay, this folder needs some design files eventually.
Yeah. So like you like accumulate over time things that kind of just like, like that was interesting. I want to do something with that.
Well, you also mentioned earlier looking at other kits or 3D puzzles, and that's a totally cool and valid and useful thing to do. Like, why reinvent the wheel when other people have done a lot of problem solving and then can inspire you to add on to that?
Totally. Yeah. I mean, I literally, like, I went on Etsy and I looked at different kits and I zoom all the way on the product images to be like, how did they figure out that joint? What have they done with that joint?
It's like the Matrix, but SVGs,
Yeah.
in planar forms. You're looking at kits and you see the different planes.
Yeah, totally. We also you did a fantastic interview, Norm, with an artist who does laser cut designs, and I learned so much from. I don't know. Do you remember the name of the art? It's on Tested. You should look it up because it's
we'll put a link.
That was so educational for me because he did stuff like instead of having to glue all the parts, he would have like a joint where it's just slightly flared out so that things would snap fit together. There are so many things, and that the way that he designed the physical joinery that I learned from. I was like taking notes. I was like, yes, this is he knows what he's talking about.
Ryan Peck asked, do you have any ideas for another project along these lines? What's the next step? If you did a book nook diorama, this is kind of a hybrid diorama, but also a thing miniature that stands on its own. What's your next challenge for yourself in laser cutting?
Ooh, I have so many project kit idea. I have tons of those folders with inspiration images. I definitely want to do something for the holidays, so keep an eye out for that. I am interested in incorporating some kinds of like, I don't want to say motion, but like potentially like things that could move. So maybe there's like a crank you can turn and it moves a piece of something. I really like the idea of sort of like interchangeable stuff. So like maybe it's this house, but you could change out all the windows, or you could put a different door in it. Almost like kind of like paper dolls. So you can kind of like choose your own adventure with the kit. I'm also interested in playing with scale. Like this is cut an 1/8 inch plywood, but like what if I cut it at twice the scale in 1/4 inch plywood and did it twice as big? You can get into more detail. There's so many different directions to go with this. I don't know, because you also do tons of laser cut stuff and lighting. Like
lighting is super fun, and it's super accessible now because it's fun just to dive into different types of lights, from the off-the-shelf fairy lights to anything USB powered, LED strips, all sorts of fun stuff. I mean, this is technically mixed media, even though you're working with your acrylic and the wood there. You're also taking stuff from a craft store like Michael's and getting foliage in there, and I love that mixed media aspect. Mixing laser cutting with something that's milled or something 3D printed just again takes it one step away from the singular process. I think always trying to make things not show the process that it was originally made in.
Yeah, it's an interesting balance because you want it to be organic and show the hand of the maker and seem like it was hand drawn, but at the same time you're also trying to like disguise how it was made in the ways that you're talking about.
Let's see, are there any other questions? Well, let's move on to from here. What was your next step?
So this is pretty close, to the final form factor, but then I went into different materials. So this was the final version that I cut in the proof grade ply, the Glowforge proof grade plywood. And so this comes, it's sort of, it's pre-masked and it's pre-finished. So it's already got this like,
Show folks here. Yep.
Yeah. So it's already got this kind of like slightly glossy, almost like a satin finish on the plywood. And it's all different stains. So there's a walnut stain on the roof and on parts of the door. The walls are all like a cherry. And then there's a couple of highlights in the lighter maple plywood. And then I also added these acrylic, glossy black acrylic details for the trees and like there's a little cat. I don't know if you can see that little cat on the front porch. So I really had fun with kind of really mixing up the finishes, because the difference between the plain birch kit, which like does show the scorch marks and things like that, you need to add dimension in other ways. So having the different finishes of plywood really helps everything to pop.
It reminds me when Adam is doing a weathering paint job, and it's always the third color that makes it. Like you do a first color, you're going to do a wash of black or something, and then you add like a burnt umber, and you're like, okay, you have two different, a dry brush of something and a wash. But then the third color that you might not think you need, it is the thing that ties it together, and it elevates to another level. And I feel like this is similar, where a third material, like if you're designing something, because it's all in the same program, if you have 3 different types of material, 3 different colors of material, adding that third factor in, combined with whether etching or engraving, that gives it just like the extra reflectivity, and it makes it stand out.
Yeah, the contrast. The contrast is such a big fact. I mean, the difference between this one, just to compare. So this one is all burnt, and I sanded off the scorch marks on this one. So
that's another way you could also do a light sanding pass.
Yeah, totally. So this is I just use like a 200 grit sanding disc on an orbital sander, and I just knocked off the scorch. It doesn't take only a second. It'll take off all the scorch marks. But so you can see the difference between this one and this one, where this kind of flattens out because, again, without the scorch marks, like the plywood's all the same color, so you're not getting as much of that dimension. Whereas on this one, you've got the contrast between the cherry and the maple, and the details really pop. It's just like you're saying, like when Adam does the little highlight passes with the chrome to make all the edges kind of glow. That's what I feel like this does.
Yeah, and it accentuates the actual physical design.
Yeah,
when you have that, and then you can light it from both inside and
exactly.
outside. All those extra overhangs and shadows. Again, it works with this very spooky and Halloween appropriate aesthetic, but it's like I'm always thinking about what the external light can do. It doesn't just hide the joins and hide the fabrication, but you can take advantage of that as well. The flat lighting is like the enemy of
exactly
of design.
That's something I need to get back. I mean, like your videos are a study in how to light and kind of create this atmospheric effect on a diorama or a figure. Like that's something I need to get better at, as kind of like the final display, because I just tuck some lights inside of here, but there is really so much you can do with different.
Oh, it's fun. Just grab a small light and just start moving your hand around. Like, oh, what is it about this that I like? Yeah. So that this ends up being the final thing, which stands alone as a miniature, or you have two applications of a display. We talk about the pumpkin, talk about the lantern.
Yeah, so I designed the base of this so that you could do it as a tabletop display, or there's an alternate version in the kit where there's little like spikes on the bottom of these, almost like floral spikes. And my thought was I wanted to put a diorama inside this lantern, so I did a stack up of just floral foam, like styrofoam. Cut that down on the bandsaw and kind of like carved out an area for the house to sit in. And then on this version, the underneath, instead of being flat for the tabletop, it has these little points that stick out, and each of these little gravestones, in this one, they all have spikes on the bottom. And so what I was able to do is create this scene and kind of like place and stick the scenery into that floral foam and create this sort of layered landscape effect. I don't know if I can show this in a better way. But yeah, there's like a grass mat on the bottom and some moss tucked in on the sides, and like little, again with that contrast, so like some of the lighter colored moss to give a couple of little pops. And when the lights are out, this whole thing kind of glows. I engraved
that was one of the coolest things. I don't think we covered it in the video you made, but the acrylic around the lantern here, you put some extra design elements there.
Yeah, so this the lantern has glass panels in it when you get it off the shelf, and I thought it would be neat to put some details. So I don't know if you can see this on camera, but I just engraved, and actually it's a cut on, it's a score, so it's a light pass of a spider web. You could also do some like cracks in the glass, and it looks really cool because it just melts into the acrylic, and so you get that look of broken glass, or of that, like it's catching the highlights of the light in different places, which you couldn't obviously do with glass, but you can do on the acrylic.
That alludes to a thing with laser cut design that it's maybe a nuanced thing, but when we think of a laser, we think of it being like a 0 point, but actually has width, right? And when you're melting, and it affects materials differently. So even though you're doing that score here, the way it melts is an extra element that you can't plan for in the computer. It's just knowing the material. The same way if you're cutting, and then having a kerf or something. These are all little things that just over time you kind of it just sticks with you. Yeah, you start to build the knowledge about, oh yeah, I remember that acrylic reacts this way when I run it at this speed, and you can start to use that stuff to your advantage. I didn't know that it would look
that cool.
Yeah.
But I was like, let me just try it, because I could have etched that. And if I'd etched it, it would have a totally different look, because it would have that sort of like textured, fuzzy kind of surface texture. But because that's a single pass, the laser's just melting that line in, it catches the light in such a way that looks like a convincing spider web. And I was like, cool, that's a really awesome effect on clear acrylic.
And is that drawn again with the Wacom tablet as a vector? And I know, programs like Illustrator have trace functions. So you have a raster, you've downloaded an image, and you want that turned into a vector. It requires a little bit of finessing, but you can turn it into a score line to have a similar effect if you didn't hand draw it yourself. Going back, I actually want to call this out, because one thing that you did that's really nice about these little gravestones is by placing it on the moss, you're taking away the right angles. Right, they kind of everything seems to be making more organic, kind of taking away. It would normally be sitting flat, but then it's sitting, on just kind of being placed on an uneven surface. This is like the most basic kind of join, a right angle join. That's what I would default to. This feels like the easy way to make something a step up, having an extra layer.
Yep, adding an extra layer. And some of it, I didn't make 4 layers. I just did 2, and then the other ones are sort of implied with the line engraved across. But yeah, I mean, that cuts really, really quickly. This is not, doesn't take very long to run on the laser, but it adds that extra little level of like, it has more dimension to it. It has more.
And it's 3 pieces, but it looks like more. And it's because the thickness of this wood is and it looks like 4 steps, even though it's just 3 pieces. I love this. Exemplifies kind of the creative laser cut design that you do. That really, like, if you want to just start with this out there in the world, if you have a laser cutter, this is a very simple way to make something look not just like 2 pieces pieced together.
Yeah, this is like the basic before you get into wobbly walls and all that stuff. Yeah, I was thinking about that. Like, if you've ever been to an creepy old graveyard, the ground is not usually flat. Like, it starts to sink in, and like the headstones start to kind of like fall over and lean into the earth, and it's like this really creepy kind of like sprawling landscape. So yeah, the moss really allows you to do that.
Well, we have a couple more minutes, so members out there, if you have any last questions, please post them now. Let's see, what other questions do folks have? Lee Marsh asks, would you use the laser to make tar paper shingles? Or use, or different materials, I guess?
Yeah, that's something that I've been interested in doing. I mostly have worked with plywood and acrylic. I'm really interested in trying out some stuff with veneer. Like, it's almost paper thin. It's a little bit thicker, but it's got that plywood, finish on it because it's wood. And paper is definitely something else you can laser cut. You have to be a little bit careful because it can catch fire easier than thicker material. But I do think it would be neat to have some different features that are made of thinner material and really play with that dimensionality. Because again, like, this has got your 1/8 inch, wall thickness essentially. But if you're working with thinner material, you can get slightly more detail. You can layer, do more layering of things. I'm interested in trying maybe like cardstock. You can also laser cut leather, which I think it smells terrible, but you can do it. And I think there's some really neat stuff with like layered laser cut leather. I've seen some really cool like jewelry, almost look like chainmail, but they're made out of like gold leaf leather, and it looks amazing. So yeah, definitely interested in playing with different materials.
Have you seen those kind of diorama displays where it's just more like layers, like shadow box things?
Yeah.
And how would you go about approaching, have you thought about a style like that, or what would be your recommendation for starting if you wanted to go with that design?
I've seen there's a couple of artists that I follow that make the laser cut or hand cut paper dioramas, and it's layers. They're doing a lot more layers. So like when I did the book nook, it was maybe 12 or so layers deep because you've got the thickness of the plywood, but theirs are probably dozens, if not 100 layers deep. One of the things that they do, these artists that make cut paper dioramas, that I think is really neat, is they play with light and the opacity of the paper. So the more layers that you have, you're seeing less light come through. So they'll light it from behind. So there'll be like a big, I assume like a big light panel behind the whole thing. And the more paper that you have stacked, you're going to get darker silhouettes in the front. So they've got this kind of like glowing effect coming through. So you're not actually seeing the light fixture, you're just seeing the glow through the paper. And I think it's really neat because with the thinness of the material, you can start to play with that opacity. That's not something I can really do with opaque material, but I would see that as a benefit to working with paper.
And that's another thing that you really can't, you're looking for happy accidents because you can't plan for that.
Totally.
The first couple times around, you just have to actually prototype and see what light looks like. Going through that diffused material.
Cut a bunch of layers and hold light behind it and see what the effect is going to be.
Yeah. Where can people find this design and what other information you want to share about it?
Sure. Yeah. So if you have a Glowforge, you can download this on the Glowforge catalog, and it comes with all the settings it's all laid out for that specific format. It's got all the settings dialed in for proof grade. If you have any other types of lasers, they're also available on my Etsy, which we'll put links to all of this. And you can get the instructions there as well. It's got a whole step-by-step of how to put all the parts together. I may also be sharing this on some other places, so you can check out my social media stuff to find out where else I'll be talking about the kits. And I think that it looks complicated, but I think it's a fairly simple to put together. So yeah, if you have one, give it a try. Let us know how it goes. We'd love to see the finished ones. I'd love to see how people display them.
I think that's the magic of this type of design, is that it looks on its surface so complex, so organic, and it is complex because it's so much design work that goes into it, but it's rewarding in that you are putting essentially together these boxes, and once you get those last couple roof pieces glued on and windows pieces glued on, it just suddenly transforms into something that looks really organic.
I think it should be a pretty simple build.
Yeah. Well, we'll have hopefully more laser projects, Jen, with Jen over the next couple months, maybe hopefully in time for the holidays. And hopefully if you have a laser cutter, or if you're interested in laser cutting, this is giving you some idea about the potential of what you can do with a laser cutter. There are lots of wonderful tutorials online. What are your resources for learning for vector design? Like any places to get started?
I mostly look at other kits. So I learned a bunch of stuff in school about vector design, like how to use Illustrator. YouTube has tons of amazing tutorials. Also, Adobe offers tutorials. If you want to get a free version, if you want to just mess around with some vector software, Inkscape is free, and you can use that in educational settings. You can try it out at home. And you can generate the same types of files that you would, SVGs, DXF files that will talk to your laser. There's tons of laser sort of kits that you can try out that are simple, and you can get an idea of how the joinery works. I mostly just study other kits. I learn from how other people have put things together. And the more of these that you build, the more that you'll learn about how the joints work and different ways of attaching things.
Yeah. I find that having a laser cutter, you have like a Glowforge at home. I have it at home. It blows my mind that 10 years ago, this wouldn't have been possible to think of having a laser cutter that's accessible. Obviously, makerspaces are places you can find laser cutters and community resources. But if you have the resources and you have the space and you can do the ventilation or the filtration, it's something that it's safe, and you can actually do a lot with it. And it used to be like, don't get a laser cutter unless you know what you're going to make with it. And certainly, don't need to invest thousands of dollars in something unless you feel like you have a purpose for it, for manufacturing, prototyping, or making stuff. But just like with 3D printing, I find that in places like Etsy, designers like you have put out designs where you can make the purchase of a laser cutter feel that extremely worthwhile and really satisfying to actually go through that process of putting something together.
Yeah, and I think now that I have one at home, because before I had a Glowforge at home, I was coming into Tested to work with the laser, and I was like, I needed to have a reason to come in and work on the thing. But now that I have one at home, it's like, oh wait, I can laser that. I can laser that. I can laser that too. All of a sudden, it's like, I imagine, I don't have a 3D printer at home, but if you have that new technology or sort of like tool in your vocabulary, all of a sudden you start finding things that you can do with it, or like, oh, I have a gift, I need to make a gift really quick and I ran out of time, like let me go find something and I can put their name on it. Like all of a sudden you can customize things. And there's also so much stuff out there. I mean, like Etsy, Glowforge has the catalog with tons and tons of designs and like graphics, so you can make your own stuff. So there's already stuff to kind of get you started, even if you're not yet at the point where you can make your own vectors from scratch. There's like so much content for you to begin using the machine and like get used to it, get that muscle memory of like how things fit together.
It really is that muscle memory. Like I promise you, like if it feels daunting, if design work feels daunting, if you build those reps in and you know, laser cut something once a week, whether at a makerspace or if you get your own laser cutter, you're gonna reach that inflection point where you will start thinking in laser cutting, and it becomes the solution to everything. And having it accessible and convenient, if you're lucky to have one at home, is just a really, really fun thing to have.
Yeah, I think in vectors when I think about making something. Like I think about them in flat shapes that I can then join together in box format. So yeah, super fun to have if you're able to get access to one.
Well, thank you so much, Jen, for bringing your
Thank
prototypes and your sketches in and sharing your design experience with folks out there. And thank you again, Tested members, for making live streams like this possible. We wouldn't be able to do this without your support. And we'll, we'll keep the comments open. So if you know, if you have questions, we'll jump in there and answer that. But you can we'll have links to your website as well. So check out Jen's stuff. Follow her on social media. You can always find us as well on Twitter and Instagram, and of course on YouTube. But I want to laser cut one of these next. I'm gonna get the design and take it home and make it hopefully in time for Halloween. Once again, thanks for watching, and Jen and I will see you next time.
Thanks. Bye. Cool. That was fun. It's always fun chatting about